We are going to learn how to solve logarithmic equations. And so when you first look at a logarithmic equation, you need to pay attention to where the variable is located. In this first particular problem, you'll notice that the variable is located on the side without the logarithm. Anytime that happens, there is no need to rewrite the equation in exponential form. So in this case, we say that if we want to get x by itself, we simply have to divide both sides by 6. And notice that they are asking us to either leave our answer in fraction form, and they don't mean with the logarithm, just a simple fraction, or round it to 2 decimal places. So in this case, we will have to actually round it by getting on a calculator. And you can either use your scientific calculator or you can get on Desmos. And so what I'm bringing in now is a picture of what it would look like on Desmos. So that's how you would actually punch it in. And because they asked me to round it to 2 decimal places, I noticed that the 8 that's in the third place is going to round the 5 up to a 6. So I would say my final answer is x is equal to 0.66. Now, the instructions on this next problem, they were actually asking you to just write it in an exponential equation, which is you just practicing doing that. So I'll do that first, but I brought this one in just so that I could have another one that I could solve. So if you had to write it in exponential form, of course you would start with your base, which is the 20. You would raise it to the power of 3x, and you would say that is equal to that decimal 5.7. So that's really all they were asking you to do on that one. But once again, I brought it in because I wanted us to actually solve it as an example. So what I want you to notice again is that the variable x is on the side without the logarithm. So if you were actually solving it and not just rewriting it for practicing that particular skill, you would simply just divide both sides by 3 and then get on a calculator to get your decimal for that. So let me show you what that's going to look like on the calculator. And so we use something in this case called a change of base formula. Unless our calculator actually has, if it has a logarithm key that looks something like this, where they have a log and they have a little box for the base, and then for you to put that in, then certainly you could type it in directly as you see it by putting the little 20 in this box and then the 5.7 here. But if your calculator, and then of course dividing by 3, if your calculator does not have that button, then you've got to input it like this with something called the change of base formula. And so just using a regular base 10 log, you would actually take the log of the 5.7 divided by the log of 20, since the 20 is your base, and then that whole thing divided by the 3. So again, with 2 decimal places, notice the 3 will tell the 9 to stay. So in this case, our answer would be x equals 0.19. Now, as we go to the third problem, you will notice that the x this time is on the side with your logarithm. And so when that is the case, you do have to write it in exponential form first. So we're going to start with our base. 3 is our base. We're raising it to the power of 3, and we're saying that's equal to 7x. Now, if we simplify 3 to the third, 3 times 3 would be 9. 9 times 3 would be 27. So if 27 is equal to 7 times x, in order to get x by itself, we will divide both sides by 7. And then if the fraction were to reduce, we certainly would want to reduce it, but in this case it does not. And so this would be a case where we could just leave it in as a fraction that is reduced to lowest terms as they're stating there. So 27 over 7 would be my answer on that particular problem. On the next set of equations, again, notice that the x this time is with the logarithm, so that indicates I'll have to first put it in exponential form. Remember that when there is not a base that's being shown here, and they spell it log, then that's understood to be a base of 10. If they had spelled it ln for natural log, it would have been a base of e. So in this case, my base is 10. I would raise it to the power of 3.5, and I would say that's equal to 7 times x. Now, when I go to get x by itself in this case, I have to divide both sides by 7. And again, I'm going to opt to give a decimal form answer. So I would be punching it into my calculator. And this is what it's going to look like. 10 to the power of 3.5 divided by 7. And if I round my x with 2 decimal places, then notice my x is 451.75. Okay, on the next problem, again, notice the x is located with the logarithm. So when that's the case, we will change it into exponential form, starting with the base of 8 raised to the power of 2 is equal to 2x minus 4. So from here, this is just a basic linear equation that I will solve. If I simplify 8 squared, I get 64. I'm trying to get x by itself, so I would now add 4 to both sides. And if 68 is equal to 2 times x, when I divide both sides by 2, then I'm simply left with x equals 34. And I don't need a decimal answer when I get a whole number like that. And then finally, on my last example problem, again, notice the x is located with the logarithm, so I'll simply change it to exponential form. 4 is my base. It is raised to a power of 2. And this time I'll say it equals to 7 times x. 4 squared gives me 16. If 16 is equal to 7 times x, I will divide both sides by 7. And so again, they talk about a fraction that's in lowest terms. So I certainly cannot reduce that. I would leave it, and x is equal to 16 divided by 7.